An aircraft is a complex machine, and when things go wrong, that can be dangerous for the people on board and people on the ground. The whole process around it to maintain is very complex, it's very well organized, but certain processes we couldn't optimize because we simply didn't know what happened to that part of the structure. And with digital twin technology and Smartskins, we're trying to optimize those processes as well. The objective of the Avatar project is to build a digital twin of an airplane in real-life conditions. And Entity Data is quite experienced building digital twins. We've built them for humans, for the healthcare. We've built them for cities, for smart cities. We're building for sports. And now we're building digital twins for the airspace industry. And a digital twin is never a technology-only project. It is a group of companies, institutions, universities working together on a common goal. And that is to optimize and to make flight safer.
Our research group at the Department of Aeronautics in Imperial College, we've been involved in the past decade in many research projects and development in the area of structural health monitoring. If you take the schedule-based maintenance out and make the maintenance by continuously monitoring the structure based on condition-based maintenance, you can have savings up to 20 or 30% of the operational cost of an aircraft. Sensing Skin is a new technology that we are developing in this project. This has the advantage of being flexible, miniaturized, reduced weight, and we can have multiple sensors integrated within the same substrate.
The Danish Institute of Technology is a research institute which is working on the advanced brain sensing technologies. It's a very complex technical challenge, but DTI and Imperial College of London are making great strides. The sensing skin can be mounted on the airplane without impacting its performance. And our partners from the aviation industry are already testing the skin on the real aircraft.
There's several ways of mounting these sensors, and it very much depends on the structure of the plane. For a drone like Nordic Wing is manufacturing, it means extra weight, and weight is less flight time. The sensor skin, which can be mounted on, in principle, any aircraft, we can integrate it into the structure. When we want to generate data, we need to go flying. And weather is often a preventive thing, or it could be a test where we simulate the real flying.
We put the wing in the wind tunnel, and the sensors that are integrated with the skin, they will record the load that the wing is experiencing in the wind tunnel. And we can go to a maximum target velocity of 15 meters per second. With the data, we can predict the deformation, the deformed shape, the strain and the stresses that the wing is experiencing, so that we can predict the remaining useful life of that wing.
First step or the first goal is to capture the data that wasn't there beforehand, and get actionable insights and derive insights through projects like predictive maintenance, improving safety, fuel efficiency. For example, British Airways, they host more than 5 million flight data on AWS as of today. So with this Avatar project, it'll add new data set and a new dimension which could open up new opportunities to improve further. So we can continue to reduce the environmental impact of the aviation industry.
The whole consortium is working from day one together on this process and to make it work. But of course, currently there's a lot of development happening with the sensor development, with the gateway development, and we're developing closely with AWS now the cloud services, the connectivity, the security solutions that are needed to make the solution work. I believe Avatar will not only contribute to a more extended lifetime of the aircraft, but also contribute to a more sustainable and comfortable way of traveling. And that is why we are proud to be part of this project.